provided by Thomas, Allgaier, and Frennis, based on the most relevant LinkedIn posts about commercial fleets in calendar weeks 28 and 29. Frennis is a B2B market research company that supports automotive suppliers with building feature-by-feature competitive intelligence that shows exactly how their product stacks up against the competition. You can find more info in the description.
So, welcome to the deep dive. I want you to imagine, just for a second, standing in this massive commercial lot. You've got the keys to a brand new multi-million-dollar fleet of zero-emission, heavy-duty trucks.
Okay, sounds good so far.
Right. The paint is flawless, your drivers are fully trained, the contracts are signed, and then the local utility company calls to casually mention that the transformer and the grid upgrades you need to actually charge these vehicles.
Oh, no.
Yeah. They won't be completed until 2028, so you basically just bought a fleet of highly advanced paperweights.
That's brutal. But it's not just a hypothetical nightmare, right? Like, if you're operating in the mobility space, that scenario is happening right now. And that's our mission today. We want to cut through all the noise and synthesize the actual operational realities of commercial fleets. We're unpacking everything from these massive infrastructure bottlenecks all the way to edge computing AI. Basically, we want to give you a sharp, actionable edge.
Because, the conversation in the industry is almost entirely dominated by vehicle specs right now. Everyone is just staring at range numbers and payload capacities.
Yeah, the shiny new toys.
Right, the latest battery chemistry breakthroughs. But if you look closely at the data from the past couple of weeks, the actual choke point of this whole transition, it has very little to do with the truck itself.
Yeah, we are definitely seeing a consensus emerge from industry insiders on this. Simon Riley and Jamie Sands brought some really critical perspective here. They emphasize that securing depot grid connections isn't just a matter of months. Like, it often takes years.
Yeah.
You've got permitting, trenching, the massive global backlog on high voltage transformers. It all just compounds.
It does.
And their point is, if fleet operators wait until the financial math on the vehicle purchase makes perfect sense before they even begin planning their depot power infrastructure,
they're already dead in the water.
Exactly. They are guaranteeing they will be years behind their competitors. The hardware on the road is completely irrelevant without the underlying power pipeline.
It totally shifts the timeline. And Juiced Commander broke down the day-to-day friction of this perfectly, I think. He argues that fleet electrification is fundamentally a coordination challenge, not a vehicle challenge.
That's a great way to put it.
Yeah, because when you operate a diesel fleet, the baseline is simple, right? You need a driver, a route map, and a fuel card. The truck can stop pretty much anywhere, fuel up in 10 minutes, and just keep moving.
Right.
But introducing electric heavy-duty vehicles alters that entirely. Suddenly, you're balancing route topography, ambient weather conditions, because that impacts battery thermal management, highly specific charging hardware compatibilities, and, of course, fluctuating kilowatt-hour pricing.
I always think of it like an analogy. It's like buying a state-of-the-art 8K smart TV, but you only have a dial-up internet connection.
Yes.
The hardware is incredible, but the infrastructure to support it just isn't there yet.
Yeah.
But when that utility company tells you the permanent grid upgrade is delayed by 3 years, what do you actually do?
Well, this brings up a fascinating stopgap solution. Jim Allen shared a look at transportable battery storage. He specifically highlighted systems from companies like Nomad.
Transportable, like on a truck.
Yeah, these are essentially megawatt-scale battery banks built directly into standard trailers, so they can literally be rolled into a logistics hub and deployed in days.
Oh, wow.
In days.
Yeah.
And the mechanism behind that is brilliant because it basically acts as an energy buffer. The mobile battery just sits there, slowly trickling power from the existing weak grid connection 24 hours a day.
So it's just sipping power constantly.
Exactly. It stores up this massive capacity so that when the heavy-duty trucks arrive, it can dump that energy into the vehicles at high speed. Mm-hmm. It completely bypasses the immediate need to rip up the concrete and install some multi-million-dollar permanent substation.
Allows operators to launch their EV fleets while the permanent infrastructure slowly catches up over those few years.
Right.
But hardware buffers are just one piece of the puzzle.
Right.
The software layer that's actually orchestrating this existing infrastructure is proving to be just as critical.
Oh, absolutely.
Bill Pierce highlighted a really interesting case study involving the Spokane Transit Authority. They implemented a smart off-peak charging platform built by FlipTurn, and they integrated it with ABB charging hardware.
Okay.
And the goal was to actively manage their depot's power draw. The result, they managed to shift 89% of their vehicle charging strictly to off-peak hours.
89%, that's huge.
Right.
I mean, to understand how staggering that is, you have to look at the normal mechanics of transit charging. Without smart software, a driver parks a bus at, say, 5 p.m., plugs it in, and the charger immediately pulls maximum power from the grid.
Right, when everyone is turning on their air conditioning at home.
Exactly, precisely when electricity rates are at their absolute highest. But what this software does is it interfaces with both the utilities pricing API and the Transit Authority's active scheduling system.
So it actually knows the bus schedule.
Right. It knows that a specific bus isn't scheduled to leave the depot again until 6 a.m. So instead of blasting it with peak-priced power at 5 p.m., the system intentionally delays the charge until 2 a.m.
When wind power might be abundant and grid pricing is near zero.
Yep.
And the economics of that 89% shift, I mean, that's what operators actually care about. By entirely avoiding those peak demand charges, they reduce their electric bus fuel costs to roughly 25% of what a comparable diesel bus would cost on those exact same routes.
That is an aggressive operational advantage. They turned a potential grid liability into a massive win.
But let me push back for a second. How does a traditional logistics dispatcher actually orchestrate this without needing a PhD in energy management? Like, you have dispatchers who have spent 20 years optimizing physical maps and delivery windows, and suddenly you require them to understand spot market energy pricing.
It's a huge shift.
You are injecting layers of volatility into a system that historically thrived on predictability. I mean, if the utility dictates that pulling power at 4 p.m. incurs massive peak demand charges, your entire freight schedule might have to be completely rewritten.
It's a fair point. Coordinating all that power is incredibly tough, which kind of leads to a radical question. When you look at the sheer friction of navigating peak demand, trenching new copper lines, and balancing software APIs, it makes you wonder if there's a way to just cheat the system entirely.
Cheat it? How?
Well, if plugging into the grid is this complex, what if we just bypass the plug entirely?
Oh, you're talking about battery swapping. Physically swapping the battery packs out of heavy-duty freight trucks.
Yes. And it is moving far beyond a theoretical whiteboard concept. This is rapidly becoming a massive infrastructure reality in Europe.
Yeah, we saw the scale of this highlighted by Roger Atkins and Andy Way. CATL, which is the largest electric vehicle battery manufacturer on the planet, has formally partnered with Octopus Energy, the UK's largest energy company.
Two absolute giants.
Right. And they are laying the groundwork for a heavy-duty truck battery swapping network across Europe using a system CATL calls QIJI technology.
Yeah, and Alexander Alanik provided the operational scope of this joint venture. They've dubbed the initiative Swaptopus, which is a great name.
Swaptopus, I love that.
And the numbers attached to it are formidable. They are projecting the construction of over 30 megahubs across Europe by the year 2035. The goal is to unlock £30 billion in private investment to support up to 300,000 trucks.
300,000, that's incredible scale.
Yeah.
Let's break down how QIGI technology actually functions, because it's not just swapping one massive 10-ton monolith out of a truck, right?
No, not at all.
The system relies on standardized modular battery blocks. So depending on the route for the day, a truck might load 1, 2, or 3 of these blocks.
Right, customized to the range needed.
Exactly. And when the truck pulls into a swapping station, a robotic sled slides underneath the chassis, unbolts the depleted modular blocks, pulls them out, and inserts fully charged replacements.
And the time it takes.
The entire physical process happens in less than 5 minutes.
5 minutes! I mean, that is the critical metric. In low-margin road freight, uptime is the solitary god that operators worship.
Yeah.
A 40-ton truck sitting at a megawatt charger for 90 minutes is a depreciating asset hemorrhaging money. By swapping the battery in the time it takes a driver to grab a coffee, you achieve diesel-equivalent turnaround times.
It's like the modern equivalent of the Pony Express.
Oh, that's a good analogy.
You don't build a hotel to let the exhausted horse sleep, right? But hitch it, slap a fresh horse on the carriage, and you keep moving.
Yes, exactly.
And real quick, by the way, if you are finding these deep dives into mobility infrastructure valuable, make sure you follow our feed so you don't miss future industry updates. We track these shifts as they actually materialize. But I have to bring up a skeptical point here.
Go for it.
The underlying challenge with the Swaptopus concept has to be standardization.
Oh, definitely.
I mean, this works in China, but is it realistic to expect fierce European truck rivals to adopt a standardized battery shape just to make these swap stations viable? How do you convince legacy European truck manufacturers like Volvo, Scania, or Mercedes who
Mm-hmm.
fight over every single millimeter of market share to agree on a standardized battery shape.
That is the engineering and political battleground right there. Because
Okay.
in a modern electric truck, the battery pack isn't just a modular fuel tank strapped to the side. It is a fundamental structural component of the chassis. It dictates torsional rigidity, crash safety dynamics, weight distribution, and thermal management. So asking a legacy OEM to surrender that much design control to a standardized third-party CATL battery box, that means asking them to entirely rewrite their engineering philosophy.
Yeah, it's a huge ask. But, if a fleet operator looks at their spreadsheet and sees that buying a truck compatible with a 5-minute swap station drastically lowers their total cost of ownership over 5 years, the market might just force the hands of the OEMs. They will build what the major logistics fleets demand.
Exactly. Money dictates the engineering. But, regardless of whether a fleet is hot swapping modular blocks in 5 minutes or using smart software to trickle charge overnight, managing these advanced assets requires serious intelligence.
Oh yeah, the amount of data these vehicles generate is unprecedented.
Yeah.
And operators right now are basically drowning in it. The problem today isn't a lack of data, it's data silos.
And the sheer lack of time to process it all. We have sensors monitoring brake temperatures, tire pressures, battery health, driver eye movement, GPS location.
But raw telematics data is totally useless if you don't have the human bandwidth to analyze it.
Right. And Ryan Crandell and Lori Olson highlighted a major evolution in solving this data paralysis. They specifically looked at Geotab's new MCP connector. What this tool does is it links live fleet data directly into enterprise large language models like ChatGPT or Microsoft Copilot using a natural language API.
I love that efficiency.
Yeah.
Because it eliminates what Lori Olson called Excel gymnastics.
Yes.
A fleet manager doesn't need to know how to write complex SQL queries or export 6 different CSV files from siloed software just to figure out what happened on Tuesday.
No, they can literally just type into a chat window which drivers have the highest idle times in the Berlin sector this week, or who needs safety coaching based on yesterday's routes. And the AI queries the massive telematics database and instantly returns a plain English synthesized answer.
It's incredible. And we're seeing this exact same principle applied to safety systems too. Aaron McCullough broke down the impact of Linux Coach Assist.
Oh, that's a great example.
Right. Instead of a safety manager spending 4 hours scrubbing through raw dashcam footage to find moments of risky behavior, the AI acts as an automated video editor. It scans the footage, correlates it with harsh braking or speeding telematics, and instantly generates a highlight reel.
So it provides a session summary highlighting the top risk behaviors and pulls pure comparisons, basically in seconds.
Exactly. It physically cuts the manager's preparation time by 50% and has been shown to reduce risky driving events by 23%. It's like the difference between staring at raw 24-hour security camera footage, hoping to catch something, versus having an assistant instantly hand you a 5-second clip of the exact moment an incident occurred. Like a fire hose versus a nozzle.
Yeah, AI is the nozzle that makes the data useful. But how we interpret that highlight reel is also maturing, which I think is fascinating. Samuel Elkins offered a brilliant perspective on this.
Okay, what was his take?
Well, when a manager gets an AI alert showing a truck doing, say, 103 kilometers an hour in an 80 zone, the immediate traditional instinct is punitive. You call the driver into the office and discipline them for violating safety protocols.
Right, you blame the driver.
But Elkins points out that best-in-class carriers are looking upstream from the cabin. Very often, a driver speeding is merely a symptom of a systemic operational failure elsewhere in the company. The real risk often stems from journey management.
Wow.
Like a sales team or a dispatcher promises a client an impossible delivery window, completely ignoring variables like cross-border traffic or severe weather. When reality sets in on the highway, the driver is forced to break the speed limit just to close the gap and meet that unrealistic corporate promise.
Wow. So you are shifting the accountability from the driver's foot to the dispatcher's screen. If you fix the route planning upstream and stop overpromising, the speeding stops organically.
Exactly. Fix the route and the
Yeah.
speeding stops. And identifying and fixing those systemic risks translates directly into capital.
Always comes back to money.
Always. Ethan Katak pointed to a recent partnership between Motive and Geico. Insurers are realizing that carriers deploying AI dash cams and actually using the interpretive data to proactively coach drivers present a drastically lower payout risk. That translates into hard reductions in insurance premiums for the fleets.
That makes total sense. But I do have to ask, like, if AI is generating the coaching prompts, flagging the video clips, adjusting the route schedules, do we risk losing the human empathy required to actually sit down with a stressed driver and change their behavior? I mean, an algorithm can highlight the speeding event, but it takes a human being to sit across from an exhausted driver, look them in the eye, and ask if dispatch is pushing them too hard.
I completely agree. Technology deployed without empathy is just surveillance. If a company uses AI solely as a punitive tool to write people up, they are going to accelerate the very crisis that is threatening the entire freight industry right now.
Right. Technology is totally useless without the right people. Which kind of perfectly sets up the final overarching challenge facing the entire industry right now when we zoom out to look at the macroeconomics and operational realities of the market.
Yeah, we have to look at the human element.
Because Oliver Temple shared a statistic that just abruptly puts all this high-tech infrastructure into perspective.
Oh, is it?
The single biggest constraint on fleets today isn't technology, it's not grid capacity or API integration. It is a catastrophic human driver shortage. There are an estimated 500,000 unfilled commercial truck driving positions across Europe.
500,000. The industry is facing a severe demographic cliff. Older drivers are retiring, and younger generations are looking at the lifestyle, the hours, the stress, the physical toll, and they're choosing other professions.
Understandable.
So therefore, every single piece of technology a fleet deploys must ultimately serve retention, making these companies places where professionals actually want to work. You have to use AI to optimize routes so drivers get home to their families on time. You have to use smart charging to ensure they don't get stranded. You have to build a company where they actually feel supported.
The human element dictates survival. And, on the purely financial side of survival, Arthur Halsall emphasized that fleets have to stop obsessing over the sticker price of zero-emission vehicles and focus relentlessly on the total cost of ownership, or TCO.
Right.
Yes, an electric heavy-duty truck demands a massive capital expenditure up front, but the operational masser, the dramatically lower energy cost per mile when smart charging is used, and the massive reduction in preventative maintenance.
Because EV drivetrains have a fraction of the moving parts of a diesel engine.
Exactly. That is where you win the margin over a 5-year cycle.
And speaking of margins, it is vital to remember that optimizing the TCO isn't exclusively about multi-million-dollar software platforms or megawatt batteries. Sometimes it is about brilliant analog physics.
Yes. Even tiny analog innovations impact TCO. Tom Johnstone showed a perfect example of this with aerodynamic mud flaps.
Mud flaps?
I know, it sounds completely mundane, but the engineering is fascinating. A standard, solid rubber mud flap on a 40-ton truck acts essentially like a parachute. As the tires spin, they throw a boundary layer of turbulent air directly into that solid rubber, creating a massive low-pressure drag zone behind the tires.
So the truck spends a measurable amount of fuel purely fighting the wind resistance generated by its own debris guards.
Exactly. So engineers redesigned the flap using a tough, structured plastic grid. It still physically blocks water and gravel from hitting the vehicles behind the truck, but it allows the air to pass right through the mesh, breaking up the vortex. That one simple analog change reduces long-haul drag by roughly 1.5%.
On a single trip, 1.5% fuel savings is a rounding error. But multiply that reduction across a fleet of 500 trucks, each running 100,000 miles a year.
Suddenly, that plastic mesh is saving the company millions in operational costs.
Right.
I laugh because saving 1.5% with a mud flap sounds like finding loose change in the couch, but across millions of miles, it pays for the whole couch.
It's the ultimate marginal gain.
But, while Western fleets are fighting for 1.5% aerodynamic savings and navigating multi-year grid delays, we have to look globally, because the scale of what is happening in the East is shifting the entire global timeline.
Oh, massively. Michael Barnard provided a comprehensive analysis of China's heavy-duty deployment, and the numbers are just staggering.
Okay, lay them on me.
China has established a target for the year 2030 to reach 40% new energy heavy truck sales. To put a hard number on that percentage, we're looking at roughly 1.6 million zero-emission heavy commercial vehicles hitting the road in the next few years.
1.6 million. And these aren't small delivery vans doing final mile runs around a quiet suburb.
No, these are Class 8 equivalents. What is critical about Barnard's analysis is the utilization strategy. China is actively displacing high-utilization diesel freight, not just running small pilot programs. They are ripping the most carbon-intensive vehicles out of the supply chain and replacing them with electric and fuel cell alternatives. Because the scale and the utilization rates are so exceptionally high, this single initiative is actually starting to break global oil demand forecasts.
Wait, really? Actively breaking global oil forecasts?
Yes.
Which poses a really pointed question for anyone listening to this right now who operates a fleet in Europe or North America. Based on China's massive scale, if they're deploying 1.6 million heavy electric trucks, building swapping infrastructure at scale, and visibly altering global oil consumption, are Western operators moving too slowly out of fear of the upfront purchase price?
No. That is the defining tension of the market right now. Optimizing today's quarterly spreadsheet versus building the infrastructure required to survive the next decade. If we connect the threads of everything we've unpacked today, the reality that plugging in requires AI to negotiate utility pricing, the shift toward 5-minute robotic battery swaps, the ability to query your entire fleet safety record with a single natural language sentence, and a 500,000 driver deficit, it paints a very specific picture of the future.
It really does.
And it leaves you with one last thing to mull over. With AI routing, 5-minute battery swaps, and total operational visibility, are we rapidly approaching a reality where the traditional role of a fleet manager becomes more of a systems orchestrator, someone who balances human psychology with algorithmic routing and spot market energy trading? And what specific new skills will you need to develop to ensure you stay relevant in that hyper-connected job market?
If you enjoyed this episode, new episodes drop every 2 weeks. Also check out our other editions on electrification and battery technology, future mobility and market evolution, and next-gen vehicle intelligence. Thank you for joining us on this deep dive. Make sure you subscribe to the feed so you never miss an update. Keep questioning the baseline, and we will catch you on the next one.